All right, well, welcome all. So Araz, I want to start right away with you. So Kayhan Space maintains a range of real-time and historical data for objects and events in the space environment. Based on this, what can you tell us about the current state of complexity, risk, and safety in LEO in particular, and do we need improved tools for managing that situation?
Well, thank you very much for having me. It's a pleasure to be here. So this is day 2. Day 1, we heard a lot about a big problem that we have, which is space traffic coordination. And we heard this morning and yesterday that this problem is going to get worse and worse, and we really need to do something about it, otherwise, it's going to be catastrophic. But how big is that problem? Is that problem real? What's the scope of it? How big is it going to be? We won't really know unless we dig into some numbers and look at metrics. So there are a lot of numbers on this, but I'm going to walk you through it, so just bear with me. On the left side, we're going to talk about where we're today, and then I'm going to talk about what numbers are telling us and where we're going to on the right side. So on the left side, 300,000 is the number of collision avoidance maneuvers that Starlink today, if you average it out, right, because the constellation size is growing and all that, but if you took the recent numbers and kind of extrapolated, 300,000 maneuvers per year that they perform, and that's only collision avoidance maneuvers. So if you do a rough back-envelope math, again, it's hard to, based on the growth of their constellation size and everything, that comes down to more than 1 a day per satellite. And think about it. Today, Starlink performs on average more than 1 collision avoidance maneuver a day. So if you're an operator in the room and used to operate satellites 10 years ago, you would remember every time you perform a collision avoidance, you would probably tell your friends and at parties that, hey, we had this situation, we performed a maneuver and got out of the way. Now that's happening once a day per satellite for Starlink, right? So that's where we are. And then we also talked about the problem of coordination with a lot of Chinese operators. So how big is that problem? We ran an analysis based on the data on satcat.com. We looked at all of the, which is a Kayhan product. We looked at all the high-risk conjunctions, and we defined it as, I think, missed distance of less than 5 kilometers. And we said, how many conjunction events do we have in a month with Chinese constellations? And these are Chinese operational satellites. And that number is 380,000. And that's a big number. So if you have operators performing a lot of collision avoidance maneuvers today in LEO, and a big chunk of it is part of the Chinese constellation, that is also a big problem. So this kind of starts to show the size of the problem, right? And then most maneuvers that operators are performing are not reported, which is terrible, because unless you know somebody's moving their satellite, you won't be able to safely avoid them, right? And also, as we know, we were talked about it, Chinese operators today rarely coordinate. So that's where we are today. Big problem. But let's look at the right chart. Let me try to explain this. This is a rough chart because we pulled ITU filings, which is in the future, right? And we kind of charted. So horizontal axis is altitude. So left is lower, high is higher altitude. And y-axis is number of satellites that are planned. And look at those packs. So we are nowhere close to this today. And the numbers that we're seeing on the left side is what we are dealing with today. So imagine if all of those satellites launch. So we don't have 5 years. We don't have 10 years to figure out how we're going to solve this problem. This is a problem of today, and it needs to be solved today. So that's kind of the numbers that I've been able to pull together to kind of talk about the size of the problem we're dealing with.
Yeah, thank you, Araz. So, I mean, there's a lot there, but just the line that most maneuvers aren't shared or aren't coordinated, right? I think that's probably fine if you're a Starlink on Starlink maneuver. You probably know what you're doing within your own constellation, but if we move over that to the other side of that chart, then that becomes, I think, a real source of risk, right? So, Andy, I want to turn to you now. The Interagency Space Debris Coordination Committee, IADC, publishes an annual report on the status of the space debris environment and the status of the environment in general. How do the findings of that report align with the situation Araz has outlined? Are the existing metrics we track adequate for that change that is coming?
Yeah, thank you, Ian. And before I start, I'd just like to extend my thanks to Secure World Foundation and the co-hosts. It is a really fantastic event, and it's a great opportunity to bring together key decision makers, operators, manufacturers into one area and really to try and dig into the detail of some of these challenges. as Ian mentioned, and as I came on, my name's Andrew Ratcliffe, so I'm Chief Engineer at the UK Space Agency. Within that role, I provide technical assurance across the agency to our various activities. But this year, I've got the distinct honour to be the chair of the Interagency Space Debris Coordination Committee. And so within the rest of my remarks, that will primarily focus on the work we're doing as the IADC to provide you some insight into the key research that we're performing. But needless to say, this is a key area for UK government as well, and this is a key area that we're investing a lot of time and attention. So to begin, I really just wanted to provide a bit of insight into the IADC itself. So the committee itself, the primary purpose really is to exchange information and coordinate our research as national agencies, and then use that research to really drive key outputs for the community. So the one that most people know is obviously the Space Debris Mitigation Guidelines. And these are the guidelines that have been embedded within everything from the UN COPUS Space Debris Mitigation Guidelines through to national regulatory frameworks. The committee itself is composed of 13 member agencies and 3 associate members. And the work itself is split between 4 working groups. So we have a working group focused on measurements, so sensors, environmental and database, so looking at the forecasts and modeling of the environment. We have one on protection and one on mitigation. And usefully on this panel today, I'm joined by 2 key members of the committee. So Laurent is part of the steering group representing CNES, and Camilla is one of our key experts within Working Group 2, working on the metrics aspects. So in Ian's question, obviously you mentioned our report. So the report itself is an annual release and is a report that looks at the status of the space debris environment. And importantly, it has 2 key components. So it has a look at the current situation, so how what is the compliance of current spacecraft and operations to the space debris mitigation guidelines. Broadly, within GEO, there's good compliance. Within LEO, within non-naturally compliant orbits, so orbits that would meet the end-of-life requirements, it's slightly more challenging. And then it also has a section which looks at future forecasts. So how is the environment changing? And within that, there's extrapolations which are provided. So we have a look at if we stop launching tomorrow, what would the environment look like? And we can see that even with the objects already on orbit, there'll be an increase in debris due to the collisions between those objects. But if we continue at the launch rates that we're predicting and at the compliance levels to the space debris mitigation guidelines, then the debris environment would significantly change. And we're predicting a 2-fold increase over the next 50 years. And so what can we do against that? And this is where the metrics topic really comes to bear. And so within the report, we're looking at trying to include metrics within the report. So there's work that's being done by Working Group 2 on environments and databases, where they have a specific action item to develop these metrics, both on a global and environmental level, but also on a mission level that can be integrated into that report. And that's really critical because it will be the first chance that we can really understand where we are in terms of the environment and where it's heading. And so we can set those thresholds and we can start looking at maybe new technology solutions, stricter behaviors that may be needed to try and curtail that growth in the debris environment in the future. Thanks.
Yeah, thank you, Andrew. I think you said something that to me sounds rather important. Maybe we can come back to that. And you talked about metrics at the environmental level and metrics at the mission level. And I think there's a important difference and distinction between those two, and we might want to come back to that here in the conversation later. So, Laurent, to turn to you, basically a similar question, but from the agency perspective. So, how does CNES view some of the trends that we're discussing already in this panel, and how we measure them?
So, thank you, Ian, and thank you, Secure Foundation, for hosting here this event. At CNES, we have the chance to have at the same place the Operations Center who is performing the collision avoidance in the frame of the EU-SST partnership of more than 600 satellites, and we also perform the analysis of the long term. And at the same time, we also regulate, so we can see the correlation between the both. Today, and we are always asked, is it a serious question, this question of debris? And the fact is that we must perhaps distinguish the pollution, the debris, and the traffic. And this is something that we really experience in our center. I would say in the altitude of the Starlink, we face more a traffic problem, and that has been described just before. And we have a lot of conjunction with Starlink, and we coordinate each week with Starlink in order to perform avoidance. And actually, this is Starlink who avoids us, and not we do not avoid Starlink. So this is a typically traffic problem. And on the higher altitude, we are more on the debris problem, and which is the historical one. So it's not easy to answer this question. That's why we have started also to study what are the different metrics which are provided by ESA or by ASI or Italy. And so we perform the studies in order to try how evolve the situation. And in these indexes, one of the key is the propagation between the different objects, and you may have time to propagate it. So we try to work on semi-analytical or samples, Monte Carlo samples, in order to accelerate the propagation and to have metrics that are very efficient. So you can see here, for example, since I'm an engineer, I like to put some graphs. Two examples of metrics that we have. On the right side, you can see the trend that I just mentioned before. You can see this histogram are the number of conjunction that we have between for a set of satellites. And on the upper graph, you see the lower altitude, and on the lower graph, the high altitude. And the red histogram show the trend of the constellation, and the blue of the debris. So this is the difference between these two areas in orbit. And on the left, the graph is something that we try to characterize is the conjunction of the orbit. So this is a graph with a theory of graph. We linked the object by the missed distance that they encounter with other objects, and you see that there are some clusters that appears, and you see the trend that I've mentioned, Andrew, which is that if you have no launch anymore, you can see that there is an increase of debris because there is some clusters of debris that can collide by themselves. So this is the kind of work we try to do.
Thank you for that. So a couple of interesting, I think, visualizations there. Looking at the constellations increasing and the debris so far staying relatively constant. We see if that trend continues over time, right?
True.
And that mapping is I think particularly interesting. So Camilla, turn to you. So as you've listened to the situation described by our previous speakers, and Andrew kind of already mentioned some of the work that you're doing on metrics. Can you just tell us how you, in your work, define metrics for measuring the health of the space environment?
Thanks. I'm very honored to be part of this panel. So first of all, let me stress the fact that there is a remarkable international effort in developing and comparing metrics to evaluate the overall space carrying capacity and to evaluate the impact of each single mission on the environment. At Politecnico di Milano, we are tackling this in an interconnected way, connecting actually the mission level with the overall capacity level. We are developing the ESA operational tool, TEMIS, for tracking the health of the environment and mission in space in partnership with GMV. In this approach, the impact of emission on the space debris environment is evaluated as a risk, which is actually a very common way to evaluate any other environmental problem outside space. And the risk is measured for a single mission as the probability of emission during its overall lifetime of exploding or colliding with other objects. And in case this happens, it also measures the effect that such a fragmentation in space will cause to the overall space debris environment. And how can we measure this effect? Going back to what was said before, we measure it as an increased operational effort in terms of collision avoidance maneuver that all the other space operators in any other orbital slot will have to put in place in order to avoid those fragments. And therefore, if we are able to evaluate that effect on short time, weeks to months, we are evaluating the effect on space traffic management, because it will mean more operation in that particular week or month. If instead we evaluate it like in that map over a very long time, we are basically measuring the effect on the overall space capacity. It has also to be stressed the fact that the indicator depends on the mission itself. So it depends on the choice of the mission architecture, on the mass, on the propulsion system, on the choice of post-mission disposal. So first of all, it can really offer a tool to operators to trade off in between different mission design, in checking the capabilities of their operation and in checking their adherence to space debris mitigation guidelines. But also it can be used for uses of evaluating the overall space carrying capacities, or even in the future could be used for insurances or for regulations.
Thank you. So you've come back something that Andy mentioned, right? Kind of the mission relevance of this, and then a tool perhaps that can also look at the long term. That's I think, again, I said it's important, but I think possibly we could discuss whether those two things always align or not, whether a mission might be, metric might indicate a mission has manageable risk, but then if you put that into a long term, you might see a different picture. But maybe that's for discussion later in the panel. Lorenzo, coming to you now, I would say that a part of the reason that we want metrics is because we do operate in this domain, and we do need to be able to do that in a way that is safe, in a way that maintains mission stability. So Telesat is working to deploy the Lightspeed constellation. As you do so, what data, what metrics have you found useful as you consider operational needs?
Thanks, Ian. Thanks a lot for having me here to join this very interesting panel. So I'd like to revert the question and address first the metrics side, because I think that metrics are something we use more during the development and design of a system, while data, they are useful at any time, of course, but they become really crucially important during the operation of a satellite. So regarding metrics, we have used really a variety of them, covering different aspects of space sustainability. I would like to mention a few things we have investigated, like metrics related to the probability of collision, but also more into the research metrics associated with the orbital carrying capacity framework, which is really discussed nowadays. Metrics related to the evaluation of the orbital congestion, as well as more constellation-specific metrics that try to determine which is the efficiency of a given design, like the occupation of orbital volume, as well as other aspects of space sustainability, like metrics to evaluate the impact of a satellite on radio and optical astronomy. And of course, we have used them differently because of the different nature of the metrics. For some of them, we are really required to evaluate them, like probability of collision is basically embedded in any regulatory framework. But even there, we didn't limit ourselves to just use the software tools that are available, which are useful, but we also developed alternative models that we think are more aligned with the way satellites are actually operated. We have used metrics to inform the operational and design choices, and we have used metrics to really contribute the operator perspective towards the development and improvement of the metrics that we have nowadays. So again, we didn't limit ourselves to just use the metrics, but we really wanted to bring into the knowledge of an operators. And it's both knowledge about the physics behind these metrics, but also the knowledge on how really systems are operated, which is basically something that is really known to the operators and more than other organizational entities. And we have really carried out a variety of works in this sense, both internally at Telesat, but also collaborating with other operators and organizations. I would like to mention a few of them, like a work we proposed and presented at the European Conference on Space Debris organized by ESA, in which we presented the comparison on different risk metrics that are used in orbital carrying capacity frameworks and how these metrics evaluate the impact of deployment of a constellation at different altitudes in low Earth orbit. And then a work we have done together with Amazon Kuiper on evaluating the uncertainties associated with the input parameters that are needed to determine the value of metrics. Even metrics that are typically used in a regulatory framework are really assess what is the impact on the values calculated by these metrics, depending on the uncertainty we have on these input parameters. And finally, a work we have done with several other operators and the Aerospace Corporation on really defining a menu of metrics to really try to achieve some high-level policy goals related to what we call kinetic space safety, which is basically whatever is related with the physical interaction of objects in space. Going instead to the data side, as said before, data are useful at any time, even for the evaluation of these metrics, but they are fundamental when we talk about operations. So I'm referring now to the orbital positioning data or data associated with the conjunction assessment. Those are extremely useful, and we have heard many of different services that are nowadays available for that. But it's not enough, I think, because I think that with the current trend in number of satellites and number of conjunction events we have in space, disorganized data is as helpful as no data at all. So there is the need for really standardization on how we communicate data in order to streamline the communication around the conjunction events, reduce the manual intervention in the management of these events, and instead foster more machine-to-machine communication, which is helpful both for the sake of space safety, but also for the sake of reducing the operational workload for operators.
Thank you for that. So there's a couple of things that my brain picks up on that, right? Is you're talking about metrics and data as a communication tool, not an operational communication, but also a communication tool amongst different parts of this ecosystem, regulators, policymakers, operators, and then to be able to do that there has to be some sort of standardization or commonality in that, and that a data just for if it's not comparable is not particularly relevant. That's thank you for that. All right, so about 35 minutes remaining. I've got another set of questions. I'm seeing a few already come in through the app, so thank you for that. We'll work audience questions in as we go here. So I want to turn to a word that Laurent, you're used on your slide, and a couple of others have mentioned, and that is the regulation word, right? So how do metrics, improving those metrics, how does that relate to policy and to regulation? So a couple of questions here. Andy, I'm going to start with you. You have engaged a lot at multilateral governance forums. So within COPUOS, within other forums like that, where does engagement with regulators and governance forums on metrics stand? The IADC, of course, has played a very instrumental role in establishing practice for space debris mitigation. Do we need a similar technical function like the IADC for overall space environment metrics?
Yeah, no, thank you, Ian. And I think in the question you mentioned, so within my role at the UK Space Agency, I've been fortunate enough to work in a variety of multilateral forums. So I've worked, so I'm the current head of delegation at one of the UN COPUOS subcommittees, so the Science and Technical Subcommittee. And as I said, I've got the honor to be the chair of the IADC this year. And so in that role, I've been able to work more on the policy side, so the diplomatic side, but then also in the deep technical side as well. And so from that understanding, it's guided some of my views in terms of where bodies such as the IADC could fit within the future. So As I spoke about previously, the IADC releases its annual report on the status of the space debris environment. And as I said, it gives, on one part, the current status of the environment, so those insights into what our compliance to the debris environment looks like, to our debris mitigation guidelines, but then also gives that insight into what the future looks like and it extrapolates into the future. And importantly, we released that report. It's on its third annual release at the beginning of this year at the Scientific and Technical Subcommittee. So the report itself is released just in time for the committee meeting, so usually in the January timeframe. And that's so it's available to decision makers and policymakers within that forum to consider and use as part of the discussions to inform their ongoing work. As part of that, as part of the work being performed by the IADC, as I mentioned, metrics is an important part, but also trying to define, well, what is a sustainable environment? What does that look like? Is it, do we have a real understanding of what an acceptable environment would be moving into the future? And critically, that input is important within those multilateral forums to try and drive decision-making. So is it new policies that need to be adopted at a national or international level in terms of stricter behaviors? Is it national efforts to develop new technology? And all of that should be evidence-based, and it should be based on technical evidence. And that's why, as a committee, we feel it's very important that report is available for SDSC as a key multilateral forum to engage those discussions. I think in terms of a technical committee, I think one of the key areas one of the key activities we can do at the moment is trying to learn from lessons learned from areas like climate and biodiversity. We heard yesterday on one of the panels around technical bodies that are used within those forums to try and guide decision-making activities and then use that to inform future policies. So I do think there's a lot of lessons learned we can develop in terms of trying to understand what a technical body could do to support that. And we did some work previously as a UK Space Agency. We funded a project called the Space Environment Sustainability Assessment Study, where we worked with Secure World Foundation to really try and understand what that technical body may look like and how that would integrate within the multilateral forum. So pulling that back to where does the IADC fit? So as you saw earlier, one of my slides was an image from our last annual meeting earlier this year, ESOC, when the European Space Agency chaired the meeting. And as you can see, as you saw from that image, the delegations themselves, there's approximately 130 delegates as part of the committee, but it's a global committee. So the 13 space agencies and the 3 associate members are from across the globe. And so when we make decisions and we publish outputs as a committee, it is representative of these space agencies and that global integrated response. So I do believe that the IADC does have a leading role to act as that, as a potential technical body that could support that decision making, to provide insights into what future policies and where the environment is going. And we've done it previously. So we heard from the director of UNUSA yesterday when she spoke about the UN COPUS space debris mitigation guidelines. And they were developed on the back of recommendations from the IADC at the beginning of the 2000s. So there is precedent for the IADC to be a leading body within these multilateral forums and guide what future responses to key challenges could be.
Thank you, and yeah, I think you look at those flags down there, and you can see a fairly complex geopolitical situation with some of those with the members there. But the IADC remains a very technical, expert-driven, forum, right? So it's a really example of how expert-level technical conversations can continue to advance progress, even in the context of the geopolitics that we're all aware of. So. I think even the images of those slides, or the flags on that slide, is a powerful example. Laurent, turning back to the national level, can you talk a little bit more about how metrics relate to the implementation of regulation here in France, for instance, through the French Space Operations Act? Can improvement in metrics help us look at the efficiency and efficacy of regulation?
At CNES level, in the frame of regulation, the story is that we started to be interested by these indexes when we wanted to measure the impact of the mission. Actually, right now in the technical regulation, you have a set of requirements that you have to respect, but you cannot write all the requirements, and there is some case that you have not foreseen. So that's why, beside the requirements, the operators have to provide an environment footprint report and a hazard report. And for the environment footprint report, we wanted to have a kind of figure of merit in order to be able to compare the different missions. So we were more interested at the first glance on the impact of the mission on the environment. So we started to build something. It was not easy. The second reason was that we have a law in France. It means that it's very strict, and we have a requirement that you have to respect by the law. And the work of CNES is to provide to the administrative authority a compliance check of the operation. And sometimes you may be a bit higher than the requirement. What happens if you are 26 years instead of 25 years, when 25 years is the requirement? If at the same time you have a probability of disposal which is, let's say, 95% instead of 90%. So you can see that there is some requirement that can compensate the others. So we wanted also to have a tool in order to be able to see if there is a slightly of a size of a requirement is if it's compensated by another one. So that's why we started to look at that. But again, the question is what we want to measure. Either we want to measure something in the environment and the impact on the environment on the mission. So we can have some indexes on that, and this, what I understand, is the sustainability index. But in the case of traffic, you can imagine a traffic without debris. You have a concern with the traffic, so you want to measure the safety of the traffic. Let's say, for example, on air traffic, there is distance between the aircraft, and this distance is given by the capacity of the system to coordinate the aircraft. So in the traffic, we wanted also to be able to measure what is the safety of the whole system. So, for example, the number of collision, a conjunction can be a metric. And you can imagine that in the future, in a world where you leave the ballistic world to a world where you have flight plan for the satellite with the highly maneuverable satellites, then you will deconflict the different trajectory. And in this case, an indicator will be to reduce the conjunction, which are conjunctions that you did not foresee. So again, we have to choose what we want to measure.
Yeah, so if I'm driving down the motorway, I have traffic rules, and I know what those rules are and how to maneuver, and know how to operate that. If someone then drops a rock in the middle of the road, then I have a different problem, right? Yeah. All right, Camilla. So turning back to the model work and the research you were presenting, as these tools, as these models are developed, and as we look at the operational experience, how can operational experience from those that are flying today be used to improve and build out the metrics you're developing?
Yeah, the operational experience, I would say, is fundamental in a way that these metrics will really be, on one side, useful, on the other side, reachable. We have now started, for example, for the TEMIS tool, the beta testing phase of the software that is now accessible through the ESA Space Debris Office. And actually, several operators, both from large constellation but also for single mission, have already positively responded. And we are open to engage with any other spacecraft operator, space mission designer, but even commission, service provider for space traffic management services, regulators, or policymaker. Because the aim of this phase is really to get a feedback by the final user of debris metrics, and on which, in particular, on which are the further capabilities of these tools, but also other that they would need in order to really make use of metrics. Because I believe that metrics are, first of all, for the users. They are not just to check users. And how they can be useful? They can be useful, as I said before, to guide operators and mission designers at the early stage of the mission design process to evaluate, to inform them and evaluate them on what would be the environmental impact of different design choices. Because, for example, with THEMIS, you can input your mission under design, and you can compare it with different options of the same mission. But also it can be used to evaluate different post-mission disposal, or to improve let's say, to evaluate the risk of the orbital slot that you are choosing to launch at, and to evaluate what risk you could cause to the rest of the orbital slot. So it highlights the need for implementing very good collision avoidance capabilities. And then, in these days, we have been hearing a lot about sustainability policies, for example, the EU Space Act, all the national laws, and all these acts will need to be implemented. And therefore, quantitative indicators will be needed to actually implement those acts. And I think it's very important to engage at this stage with operators, because we are in a moment where we are trying and starting to define thresholds, so to say what is good and what needs to be improved. And we want to do that in a way that is not only achievable and good for the environmental level, but also that must be achievable with technology, or it could identify what are the current technologies that we need to push in order to, in the future, go down to these thresholds.
Anyway, a lot. What I'm hearing, Camilla, you talk about is different levels and different. If you look at the life cycle of a mission or the life cycle of a policy, even different levels and stages of that where metrics and this kind of improvement can be used. So we're talking a lot in this panel about using metrics at the design phase, right? And I think a lot of times I think about metrics as something that we show that we're going to use for what we're doing during operations, right? So I think, and then where in the policy evaluation and process these tools come into is also something we're highlighting here. Going to, with that, turn to back to our operator. Lorenzo, in your first set of remarks, you mentioned some of the work that you were doing with other operators on assessing potential technical metrics and potential thresholds as proxies for some of the qualitative policy goals that we're talking about in this panel. What have you learned from these analyses? Is there anything you want to further highlight in that?
Thanks. Yeah, first I have to admit that we didn't come up in the end with any threshold associated with the metrics we have identified. So summarizing, the work we have done was really to identify this high-level policy goal connected to kinetic space safety. And we identified 4 of them, which are long-term sustainability, space safety, so more in the near term, and then efficient use of orbits and equitable access. And after that, try to define measurable, actionable objectives or metrics that can be used to track whether or not we are going in the right direction with respect to these high-level policy goals. And I would say that the most interesting part of that work, and from which I even learned a lot actually, was a discussion around the metrics we have identified. So for each of the one we identified, we came up with advantages and disadvantages, which is basically what a metric can and cannot measure. The main limitation and the sensitivity to assumptions of these metrics is basically how sensible these metrics are to the uncertainties we have around the input parameters that are needed for their evaluation. And finally, and I would say even more importantly, that was probably the most interesting part, was the use cases and intended users of metrics. And here is the main point of my talk today. That is, I really believe we need to move away from thinking that metrics are only meant for regulatory frameworks, and that any metric is useful or adequate to be used in a regulatory framework. And I really want to make an example here. For example, one of the metrics we identified is the number of risk reduction maneuver or collision avoidance maneuver that a system will face once in orbit. So I really believe that these kind of metrics are not really useful in a regulatory framework. And I would say the reason is at least twofold. So first of all, it's sensible to a lot of assumptions and uncertainties around input parameters. And second, the same number of risk reduction maneuver, collision avoidance maneuvers mean different things to different operators. So large operators, we talked about before, the number of conjunction and collision avoidance maneuvers that Starlink is doing, of course, is not that any operator could deal with that number. So there is no way we can really regulate this inside the regulation and national and international regulations. But still, I don't think that this metric is useless, because we need to remember that at the end of the day, the operator is the first to pay off its bad choices. So it is in its own interest to evaluate the number of maneuvers he's going to perform once in orbit and understand whether or not the architecture it has in place to address this number of maneuvers is suitable or not. And based on that, take different decisions about, for example, orbit selection. So, I mean, the main conclusion of this work that might be obvious is that there is no one-size-fits-all metric, and that different metrics serve different purposes and are meant for different users. And this is not really a final work. We wanted to actually foster discussion about this classification we have proposed and gather feedback about that. And I think, once again, stress the importance of involving the operators in these discussions.
So Lorenzo says he wants to foster discussion. I'm curious if anybody on the panel has any thoughts based on the, I think, challenge Lorenzo offers to not only think about, or not purely think about metrics as regulation, but look at some of the other relevant operational aspects of them. So I don't think anybody on the panel said we were only using these for regulation, but I'm just curious if anybody has a perspective on kind of where that balance is there. Nobody wants to take that on. Surprising.
I stress what I already said. So I stress the fact that the first idea of this metric is really to guide operators, to inform them on what is the risk of their mission and what is the risk on different orbital slots. Because this metric, if aggregated, some of them, not all, I agree with Lorenzo, can also give the riskiness of an orbital slot. And so they are, first of all, there to inform. They are also there to show operators what is the consequence of not performing a collision avoidance maneuver, because a choice of not performing a collision avoidance maneuver, which always is not the case. Usually collision avoidance maneuvers are performed, but creates problems in very different orbital slots, but also it shows the need, for example, to improve in data sharing, it improves in tracking, because, for example, in some case the risk is high because it is high due to non-trackable objects. So how can you avoid a non-trackable object? And but then on the other side, I'm not an operator, and I really think that an environment which is regulated is an environment where more and more useful mission can fly. So in order to avoid not, let's say, mature use of your orbital slot, which happens actually in some cases, at the end you always need regulation like you do for any other environmental problem.
And I think the only thing I'd add to that, and I think it's been picked up by yourself, Ian, and the panelists, is that there's a lot of different work being done on metrics, and they are of different types and different flavors, and they consider different elements. And so We've done work as part of the IADC, but also nationally to look at the range of metrics that are being developed. And I think we our last count counted about 40 different metrics that are being developed, whether they're rate-based, risk severity, all considering different types of criteria, whether they're based on collision risk or collision avoidance maneuvers, all the way through to how do they consider some of the topics that we've discussed already at this conference, whether it's dark and quiet skies and the impact on interference with ground-based astronomy, whether it's some of the ablation topics that was discussed yesterday, how do they get factored in? And so it's a very complicated area, but as Camilla says, it depends on how the metric is to be used, whether it's to be used by an operator or a manufacturer to drive their design choices, whether it's being used as a policy tool to set thresholds and understanding on how the environment changes. That also drives what metric is adequate for the application, essentially.
Yeah, just to add, I fully agree with what Andy said, and I would like to add the fact that these metrics can be useful for the designer in order to know if they design a zero debris footprint, for example, a satellite. On the other way, I think my message is that it cannot replace the regulation, because regulation is something which is wider. Like for the aircraft, you need to have aircraft who are able to be, who are safe for the passengers, are able to be inserted into the traffic. So it's the same regulation will guarantee you that you design a spacecraft and you design the operation the way you operate, and you are a good operator, an operator that is able to operate in order to ensure the safety and the sustainability.
So, Araz, I want to turn back now to the role of the SSA ecosystem. We've got a number of commercial SSA companies and a number of stakeholders here in the room that are part of that ecosystem. I'm also going to try and weave in an audience question here. So one of our audience members is challenging us that maybe it's not possible necessarily to know if conducting a collision avoidance maneuver is always successful in avoiding a collision, or it's not possible necessarily to know if removing a debris object is going to always remove future collisions. So the question is, how do we measure the benefit of some of these measures, and what can how does the SSA ecosystem help us do that?
Well, that's a great question. So I'm going to give a long answer, because I'm going to use some of this information. So on satcat.com, what we do is that we've collected a lot of data that's open source and available. That includes also metrics, and also includes algorithms that can be used to calculate metrics. So the one difference between a commercial company and a government entity is that the commercial company can do a lot more as long as the board agrees and you can do it. But government entities always have to abide by a lot of laws, and they have to deal with budget issues. So we take advantage of that fact that as a commercial company, and others do as well, we try to do as much as we can to play our role in bringing the information and providing information to everyone as much as possible. So for example, on a daily basis, we do TLE level, because that's what we're allowed to do, TLE level conjunction assessment, catalog on catalog, and publish it on SatCat. And based on that, we produce a lot of statistics. So for example, what was today, what object in orbit is causing the largest number of conjunctions? What company is dealing with the largest number of conjunctions? And stuff like that. So there's a lot of them. Also, we pull in space weather data, calculations on that, and we provide it publicly. Now, we do that because we strongly believe that providing more transparency to both operators and also regulators is going to help drive better decisions. And I very much agree with the statement that we can't have a one-size-fits-all kind of approach in metrics and also in regulations sometimes. So I know operators kind of get scared when they hear regulations, because let's be honest, industry has been moving really, really rapidly. And sometimes if we have regulations that are not well informed, they could actually throttle innovation and slow down the innovation versus making it safer and more sustainable for everyone. So there's a fine balance there. And also, the other thing that we have to remember is that setting regulations could be easy, but making sure that everybody's actually following it can be very difficult. I have a lot of examples of regulations that exist today that operators have to abide by, but I don't think they're being monitored. So if you put in your license that this is what I'm going to do, And if you don't do that, how many times do you get caught today? So kind of going back to that question, commercial industry can help with these things, right? So, soon we'll have, I'm kind of, not announcing it, but like on SatCat, we're planning on doing a lot more than what we do today in terms of transparency and public information. And the purpose of that is to fill a gap that exists today. A lot of things happen in space that operators know. There are a bunch of operators in the room, and they know, they talk to each other, and it is kind of some of the known issues, but it's not known to public because it doesn't get published anywhere. It doesn't get reflected anywhere. So, commercial industry, one of the things we can do is to fill the gap every time there's a gap that can be filled, and it makes sense for us to do it. So I'll keep it at that.
So transparency, right? So a metric is only useful if we're able to compare activities to it and use it as a benchmark, right? A metric for just to have a number is not useful, right? We need to have a way to use it. All right. So we have got about 8 minutes left. I'm going to try to move through some of the audience questions here in a somewhat rapid fire situation. The most popular audience question, I think it's most popular for a reason. We've talked in this panel a little bit about global reference thresholds or indices, right? And we know we have some of these in non-space domains, the IPCC and the 1.5 degree being the most famous one. But we don't have this for space. We don't have a global environmental threshold or reference point for space activities. Should we have one? And what should be included in that global reference point? So if anyone wants to, that's open to anyone or everyone on the panel.
From my perspective, we have already too much uncertainty when we deal with a single aspect. Try to combine everything together in a single index might result in actually having a worse description of what the environment health is. So imagine you are combining uncertainty on uncertainty on uncertainty. So you may come up actually with a good number that describes the environment as behaving in a good shape, but it's maybe just due to the sum of uncertainties that you have accumulated during the process. So that would be my first reaction.
Maybe I can spend a word on actually the work that the IADC is doing in this direction, because the IADC is working in defining what ideally a sustainable evolution of the space debris environment is. Actually, we have already a proposal to be approved in the next IADC meeting. And how metrics can be connected with this global environment. I can do the analogy with climate. No? In climate, we have decided the degrees centigrade, so we need to decrease the temperature of. We are also studying how different metrics, we have selected some, they answer to the needed requirement to be able to measure the status of the space debris environment, and we have identified not one, but some metrics. These metrics are both mission-related and environmental-related, and we are studying the correlation among them, because there is a correlation among them. And the idea is that if these mission metrics can be aggregated to actually see what is the impact on the overall environment. So we are not there yet to define what the threshold is, but at least we are defining what a good increase of the population is. Why good? Good to guarantee the future use of space.
And just to build on what Camilla was saying, I think as was said previously as before, in our report on the status of the space debris environment, the IADC is working towards developing these metrics through the great work that Camilla and her colleagues are doing. And the intention is ultimately to have an acknowledgement of what a threshold may be and what metrics may be used to measure that. So that will be published and produced and put into the multilateral system where it can be discussed more broadly. But there's obviously then going to be broader considerations, whether it's economic, other areas which will guide how those thresholds and those metrics are interpreted. from my perspective, and as I said earlier, I think it's then also important to look at other forums where technical bodies have been used to inform decision making. So decisions are appropriately based on technical evidence, but then also that recognizing that there are wider considerations on how they're used and interpreted and then acted upon ultimately.
And I think something else, Camilla, you kind of mentioned is, at least so we can think about a threshold or a metric or index for space debris environment, but there are other aspects of the space environment that maybe that would not necessarily include. So we talked about atmospheric ablation yesterday. We've talked about dark and quiet skies, right? So that Lorenzo, a single metric or single threshold to rule them all, not necessarily, right? But looking at that different aspects. I want to really quickly get to another question here. Lorenzo, you mentioned all the uncertainties that we're dealing with. There's a question here that says, yeah, we do these calculations through computer analysis and computer models and a lot of this, right? Shouldn't we also be providing confidence measures and describing the uncertainties around these things? So, anybody want to react to that? Should we do a better job of describing the uncertainties when we're putting this information out? Yeah.
I can go first. So absolutely. So I'll give an example. So it is a very good practice for operators to publish their ephemeris that they have generated based on the GPS on board. That's the most precise source of data you have. A lot of operators don't, even though they're encouraged to do it, and sometimes they're actually forced to do it. Some they don't do it. And sometimes they do it, but because they don't publish their uncertainties, that trajectory is useless. You really can't use it, because if you tell me I'm here and you don't tell me how certain you are or uncertain you are, if you're not publishing your covariance, then I can't use that. So absolutely. So if you are publishing a data source, you have to publish your uncertainties around it. It's just that you can't. Otherwise, it's not really reliable, and most choose not to use that data point if they don't know how certain or uncertain you are about that.
On a different aspect, so uncertainty, but not strictly related to orbital positioning. But so I would say that yes, to answer your question, and there are, I think, a variety of aspects. And I think the most representative one is the evaluation of the light pollution for a satellite, in which we currently don't have any standardized, reliable model to estimate what is the impact and what is the visual magnitude of a satellite once in orbit. But doing this before the launch of the satellite, because if we want to take action to mitigate the brightness of a satellite, the only way we can do that is by mitigating it before the satellite is launched into space. There is not much we can do once the satellite is already there. And I think that it's kind of strange to see that we have visual magnitude already appearing in regulations, but we currently don't have any reliable model to estimate the brightness before launch, and also standardized that is used equally by all the parties and all the operators worldwide.
That's kind of interesting. So yesterday it was actually kind of mentioned in one of the panels that the IAU magnitude threshold or limit is an example of a good practice, right? It's working, right? And so Lorenzo, I think we can agree that it is an example, but then there's even you're challenging us that we need to think about that a little bit more on the ground side. So, all right, the clock has gone yellow, but I'm going to use the moderator's discretion to get a final answer from each of you, just very briefly, because we're at the point of holding people from lunch, which is never a good position to be in. We've talked a lot about better measurement being good and being important. I think probably all six of us agree that better measurement is a good goal. Let's get to concrete elements of that. What is the single most concrete improvement you'd like to see in measurements in the next 5 years for the goal of sustainability? So if you can improve a measurement or something, a data point that you use or you research, what would that one be where the biggest improvement could make the most difference right now?
I'll go first. I would like to put operators on the spot with this metric. To aggregate risk, we can say probability of collision, for your constellation that you could mitigate and you did not mitigate.
Anybody got better than that?
I don't know if I'm going to answer to your question. We have talked about the metrics and the figures and the threshold, but because we need to quantify what is the situation. But between the experts, we already have a target that we can share and be all be all agree on it. Right now, we know that we are able to perform operations in the current situation environment. So our first target should be to keep this environment and this level of debris. We cannot decrease it. We know it's not possible, but we can maintain it first by performing ADR on few derelict spacecraft or stage, which cause problems today. So this is the first point. The second is to respect the mitigation guidelines. We know that in the trend that the mitigation guidelines are more and more respected, and it has an effect on this population. And the third one is to avoid to have a collision, because it was said yesterday that the debris curve does not increase and the traffic increase, and it's the proof that the operators are responsible. Yes, it's true, but you need one or two collisions that, in order that the two curves are the same one. So it's really necessary to improve the coordination, not to have accident, in order to have a good consequences on sustainability.
Going ahead on coordination, so we have accurate data, for example, related to the orbital position of satellites. The main problem today is not having the data, but sharing them, and not just between, operators for which the coordination has been historically good, but also with operators with that has been historically very difficult and challenging. So yeah, that would be my answer.
I look at the main uncertainty that we have in the implementation of these metrics is the explosion rate. Indeed, the model that we released doesn't include the explosion rate. It would be very useful if operator would share the history of their failure, because they have it, and the cases of explosion, because we know we can reconstruct them when they happen, but is a huge work, because we know that the effect of explosion is very large, and we need to include it in these metrics.
I think maybe just broaden out the question. I think in terms of the near term and would value the metrics, as Laurent said, it needs to encourage operators and manufacturers to comply to the space debris mitigation guidelines. These are established practices that are proven how we can manage and mitigate our impacts on the environment. And then longer term, I think it's then moving towards an established threshold and taking it to forums such as UN COPUS. And as we heard from the director in the UNUSA yesterday, COPUS has over 102 member states. It's a fantastic forum to bring these conversations together. And if we can go to that with an agreement on what a threshold and what a metric should be, then it's a forum where we can start making decisions and identify real action, whether that's stricter behaviors or looking at novel technologies such as active debris removal.
All right, well, thank you all, and thank you for indulging us for just staying over a little bit more, because I think that was an important question. So some practical steps, both near term and kind of the long and medium term. So thank you to the 5 panelists. Thank you to the audience. Greatly.